You guys can decide if you want to spend more time on it, we can, why not, or we move on to a new topic. We'll do a consensus, whatever you guys want. Okay, geometry. Pretty much always the same style of question. There's two forms of them. One is Pythag, and the other one is similar triangles. So it's either Pythagoras or similar triangles. The similar triangle is always the same similar triangles. They'll be like, let's just say, it'll be, you know, this is 3, this is x, this is 5, and then this whole distance is, let's say, 10. So the idea is smaller the big must be in the same ratio as smaller the big. And then you'll eventually find x from that. Once you've got that, you should be able to continue it. I did it numerically. It usually will be algebraic. So you would have been like a on r, x on square root a squared minus r squared, whatever. It's the same, pretty much same concept. Okay, I'll get rid of all this. So there's similar triangles, or there's Pythagoras. Then the next thing you need to know with geometry, because they're usually going to be spheres or circles of some sort, is radius. Radius occurs everywhere. I think everyone forgets that. So they usually see A here, and what they forget is this is A, this is A, this is A, that's the one that they need. This is A, 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 right? Don't forget that, because that's what you'll need with geometry questions. For circle ones. All right, here we go. A cone is inscribed in a sphere of radius A, centered at O. The height of the cone is x. Yep. And the radius of the base is r, as shown in diagram. Show the volume is given by this. It just goes show. See, that's what I mean. Like maybe that's going to be hard, you know. So just do double I. The answer's in front of you. Just go and differentiate and do the stuff, right? But we're going to start with I. It's fine. So what do we know x equals to? Well, x would equal to this distance, which is A, right? Plus what? This distance. No, that's not R. R is the radius of the circle down here on a cone. So the radius goes like this on the ground. You get me? Do you understand that? For a cone, if that's how you want to see it, but no. This distance is what? Think. Look. Yeah, there we go. Square root of a squared minus r squared. Pythag. I told you there's two types, either Pythagoras or similar triangle. Done. You have a relationship now of x in terms of a's and r's. That's good. I don't know if we need it, but we have it. So we'll see. What's the volume of a cone? Okay, what's the volume of a cone? 1/3 times pi r squared, which is literally r squared in this case, times height, which in this case is x. What's the only difference between what I've got here and what I have here now? What would be the only thing that needs to happen now? So
the x in the first one, not putting that one.
Get x and put it in here. But if I do that, then I won't have x's. So wrong one. Again, look at this.
Rearrange this one sometimes.
But what letter am I going to rearrange and find? What letter do? Ah, that's the one. There's an R here. There's no R here. That's the giveaway, not the x. X is already in the equation. So you're going to make r the subject. So that means you would go and do x minus a equals square root a squared minus r squared. X minus a all squared equals a squared minus r squared. And lucky last, r squared equals a squared minus x minus a squared. R squared. Do we agree? All right, now I think you guys know the rest. See, so that wasn't easy. If you didn't know to just start like that, the way I started, to find a relationship for x, You would have never been able to get that out. But that's why I started with that first. And then a squared minus x squared minus 2, so that becomes plus 2, minus a plus a squared, but then that becomes a minus again. This and this cancels. I think we're done. Oops. Yep, we're done. Bring the x in, 1/3 pi. I get 2ax squared minus x cubed. Cool. Double I. Blah, 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 blah. Let's do it. Okay. I don't like it like this, yeah? If there's no number, if there's no x in front, which means I'm not going to use product rule, then I don't really like it like this. I'd rather expand it. So we're going to go and do this. 2ax squared pi on 3 minus, I guess, pi x cubed on 3. Okay. dv on dx. Bring the 2 down. 4a pi x on 3. Bring the 3 down. 3 pi x squared on 3. Equals what? 0. Factorize x out. I guess and times everything by 3, so we can get rid of this annoying 3 here. So 4a pi minus 3 pi x equals 0. Is that cool? So I times this one by 3 again and factorize the x out. Yep, we're okay with that. If it's too quick, you do it your own slow way, it's fine. Doesn't matter. X equals 0, 4a pi equals 3 pi x. Get rid of the pi, divide by 3 as well. X equals 4a on 3. Now what do? Feels like you've done a lot of math, but you're not done. You have to prove its nature. So second derivative, squared d squared x squared. That's how the second derivatives are written. 4a pi on 3 minus 2 pi x. Sub in x, right? That's what you do now. What is 4 lots of something? Take away 8 lots of something. Well, it will be negative 4 lots of something. So equals to negative 4a pi on 3, less than 0, max. Less than 0 only if a is positive. And a has to be positive because it's length. Because if a was negative, then you can't conclude this, right? You can't exactly say it's always less than 0. But we know that is because a is greater than 0. Stop, go back, reread the question. Did I answer it? If so, you're done. Find x. You must give reasons done. Find x, and I did find x. Doesn't say to find the volume. Finished. Okay, any questions? No? All right. Let's do the next one. Have a read. I think it's the last one, like I said. Have a read. Show that the area of ABCD is that. Okay. Let's do this. Diagram shows a rectangle ABCD inscribed in the region by the parabola y equals x squared on 4 and the line y equals to 6. Show that the area of ABCD is given by this. Okay, so to find area of ABCD, obviously what formula am I going to use? Area of a rectangle, which is just base times height. Well, I think we know what the base is. Let's do the base straight away. What would you say the length of the base is? Don't overthink it. Yes, thank you very much. That's x plus x. Because of symmetry properties, that would be 2x. Good work. So we've got our base, 2x times, now we need our height. Okay, well, what do we know this whole length is? Don't overthink it, it's right there again. Think about graphs and anyone? That whole length?
It's 6.
It's 6. It is 6. Very simple. Isn't y equal to 6 here? Exactly. Oh. Yeah, that's 6 right there. Y equals to 6. And then we want to find obviously this length now. That's meant to be the harder one. Again, if you think about, you've got x there. How do I find that value there? That specifically touches this point. What do you think? Okay, what letter is this usually? If we're talking about something like this. What letter? If it's vertical. Yeah? Y. So how do I find y? At this point. How do you find y of something at that point? How do you usually find y?
Differentiate.
That's, no, not differentiate. Differentiate, you find stat points or gradients. How do you usually find y? How would you usually, like if I gave you, I don't know, anything, like, I don't want to say the answer. If I gave you anything, any equation, and I ask you to find y, I hope your head says, sub something in, anything, sub x as anything in, and you'll find your y value at that point, isn't it? How did you guys find your y values for your stationary points? Sub x back into the function. So how do I find this length? Sub x back into here, which is just x squared on 4. This length is x squared on 4. Isn't it? Of course it is. If I said 5, I know all of you would have subbed it in. All of a sudden it's x, and you can't do that. You've got to think the exact same way. All right, that's the length. So obviously, what's BC? 6 minus x squared on 4. I know, just going from the conversation you and I had the other day, you can see the theory there. You've got to know that stuff. You can't just always jump into, I guess, I don't know, harder and harder questions. You've got to know your theory. You've got to understand. If I see an x, how do I usually find y? Just sub it in. Don't overcomplicate it. All right, expand it. I think we can all see the answers there. 12x minus x cubed on 2. Find the dimensions of the rectangle. So the area is a max. All right, here we go. Double I. dA on dx equals 12 minus 3x squared on 2 equals 0, times everything by 2, times 24 equals 3x squared eventually. Divide by 3 gives me 8. Square root it. Then I'll do my second derivative. Equals negative 6x on 2. Sub this in, negative 3, yeah, root 8, which is less than 0, max. But we're not done because the question said to find the dimensions. So the dimensions are, I think we said 2x here, and what was this one? 6 minus x squared on 4. So the dimensions are, dimensions equals 2 root 8 and 6 minus root 8 squared, which is 8. 8 on 4 is 2. In case you guys needed that. So dimensions are 2 root 8 and 4. That will give me the maximum possible area of a rectangle that's constrained within a parabola of that function. Done. All right. Let's pause that there.